Okay, so I'm just going to do this video on Solidworks and basic simulation. My name is Joe Fordyce. I'm Software Application Engineer at MGC Technical Service Limited. So I'm just going to go through what we're going to talk about today. So start off by talking about who we are and what we do. Then we're going to move on to talking about why you should choose Solidworks as your CAD/CAM system of choice. And then I'm going to put on a design and simulation demo that I've put together, and then I'm going to round it off by basically going through some of the simulation packages that are available through Solidworks and some of the features that they have as well. So who are we? We're MGC Technical Service Limited. We're an independent company based in Aberdeen, and we devise different software and set up solutions for companies to help them maximise their productivity and efficiency. We work with CAD/CAM systems, CNC programming and resource planning, and we're authorised resellers for Solidworks and 3D Experience, Simco and Plan de Campagne. So why choose Solidworks as your CAD/CAM system of choice? Well, for starters, Solidworks has got an efficient 3D design. It's quite straightforward to use, and it's a parametric design system. It allows the user to, at any point during the design process, to edit the design, and it's all done quite easily. The graphics also allow the user to visualise the designs with realistic renderings and animations without a physical part actually being made. And this also allows the user to evaluate aspects such as the mask properties and interference, meaning that any errors can kind of be avoided, and that'll save time and money in the long run. Compatibility is also quite a big benefit of Solidworks, as it is a widely recognised CAD system. The chances of a competitor, supplier or customer using this software are highly likely. So Solidworks also provides the user the ability to share editable files with suppliers and customers in a format that they can open, even if they do use a different software. So talking about a talent pool, Solidworks has got quite a large talent pool, as it is offered in educational institutes throughout the country. And therefore, as an employer trying to find an engineer skilled in using the software, it's not going to be too difficult. However, if there are engineers out there that haven't got experience with this software, there is quite a short learning curve with Solidworks. The Solidworks has got built-in tutorials, lots of presets to make designing speedy and stress-free, and there are also lots of tutorial videos available from different media platforms such as YouTube, which can really help you sharpen up your skills. Solidworks also has quite a large support because there is a staggering number of active users across the globe. Finding answers for Solidworks questions is actually quite easy. Also, when purchasing Solidworks through MGC Technical Service, you will also receive support for the duration of your full Solidworks subscription from engineers and technically trained staff here. So I'm going to go through this design and simulation demo that I've put together for you. So basically done a design for a pipe system, and I'm going to sort of show the flow simulation through that pipe as well. Okay, so start off by loading up Solidworks, and we'll start by getting a new part together. So click on part, click OK, and here we've got our workspace. So we'll start off by specifying the material. So right click, edit material. I'm going to choose AISI 1020, apply that, and close that window down. Okay, and if you want to change the units as well, you can go down at the bottom right of the screen here and click there, and you can select the different ones. I'm going to use millimeter gram in second for this one. Okay, and then what I'm going to do is I'm going to turn off, there's a tool that I use in the options. I'm going to actually switch off just now to kind of show you the benefits of this. I find it quite beneficial for kind of saving a couple of clicks here and there. So what we'll do is look at an example. So start a sketch on the right plane. So right click, sketch, and draw just a basic line here. So draw that line out, and now normally what I want to do, if I want to get a definitive line, length for that line, is I'll smart dimension that and say 50 millimeters. So that's that defined, and the length of that line is 50 millimeters. So get rid of that. Now I'm just going to go back into tools and down to options, and then the system options. We'll go down to the sketch here, and what I'm looking for is to enable the on-screen numeric input on entity creation. And I also highlight the create dimension only when the value is entered, and I'll show you what that means in just a moment. So click OK. Okay, and what we'll do is we'll just draw this line again. So like I say, you draw the line out, and 50 mil ballon. Okay, so smart dimension that, like I say, just to confirm what length I want that line to be is 50 millimeters. So I can do it that way. But the feature I've just turned on actually makes this just a little bit quicker. So click on the line and just click the start point for the line and the direction I want the line to go in. And this little white box lets me enter the value that I want the line to be. So if I type in 50, and this will make the line exactly 50 millimeters. And because I've entered that value, it automatically dimensions that for me as well. So let's say it just saves a couple of clicks. So let's get rid of that just now. And what I'm going to do is I'm going to start drawing the sketch for the pipe here. So circle. We'll start off and we'll do 20 millimeter diameter. Internal diameter of 16 mil. Okay, and like I say, I've got the dimensions there as well because I've manually entered them. So that gives me the sketch for the pipe. So now what I'm going to do is I'm going to move across to the front plane, normal view, and sketch. Oh, sketch on the front plane. There we go. So what I'm going to do is I'm going to draw the path I want to sweep this boss along. So start off the line, so 80 mil, down 60 mil, and along 80 mil. Okay, and like I say, the dimensions are all there as well because I've manually entered those figures. Now obviously because it's a pipe, we can't just go straight around the 90-degree bend here, so I'll need to put a fillet in there. So up to fillets, and I'll put in a fillet of say 15 millimeters. And then all I'll just do from here is just click on that node at the corner there, and tick, and there we go, we've got the bends there. The fillets are applied, radius 15 you can see there as well. So let's cross out of there. Okay, so now I've got the profile and I've got the path I want to sweep it along. So now what I'm going to do is go to features and sweep the boss base. And I'm going to select that circular profile and then the path I want that to go along, which is here. And as you can see, that pipe is about to show up, so I tick, and there we go, we've got our pipe. Simple. Okay, so now what I'm going to do is I'm going to go to start the flow simulation. So this is the flow simulation tab here. If you've not got any of these tabs, what you can do is just right click on one of those tabs, go down to tabs, and there you can see a list of the different tabs you can actually set up on SolidWorks. Also I want the flow simulation tab, but if that's not there, then you can put in the SolidWorks add-ins tab, and then click on that tab, and there's SolidWorks flow simulation there as well. Okay, so let's say I'm going to start off with flow simulation. Now what I need to do first of all is I need to put lids on the inlet and the outlet for this pipe, just so I've got a computational domain. So to do that, I'm just going to go to tools, again on the flow simulation tab, click on tools, create lids, and just click on the face of the inlet and click on the face of the outlet. There we go, and then hit that tick, and we've got our lids there. Now you can do these manually yourself as well, but I again find this just a little bit quicker. Okay, so now what I'm going to do is I'm going to save this model. So let's say it's flow simulation, so what was that one there, because that's one I created earlier. Click yes. Okay, and now what I can do is I can go into the flow simulation wizard. There we go, and I'm just going to name the project flow simulation. I'll click next, and then I need to decide the unit system I want to use, so SI units. Click next, and then the physical features of the internal or external. I'm going for gravity, but I'm going to move the gravity to act on the y-axis as opposed to the z-axis, just so that in relation to the model, the gravity is acting where I want it to act. Okay, so click next, and then I've got to click the fluid I want. So I'm going to go for water, so liquids, and down to water. Now there's a couple of different ways I can do this. Just highlight water, I can click add, and then it shows there. Or alternatively, I just double click on water and it adds it in as well. Okay, so let's click next, and next again. We'll go right through the finish here. Okay, and now this kind of grayed out box here, that's our computational domain. That's what we're going to be analysing here. Okay, now what we need to do as well is we'll need to set boundary conditions at the inlet and the outlet. So over to boundary conditions, right click, insert boundary condition. We'll do the inlet first of all. Okay, and what we want to do is we need to select the face. Now we want the boundary condition to act on the inside face. So to do that, I'm just going to hover over the lid and I'm going to right click and then select other, and that lets me select the inside face there. And what we'll do is we'll select inlet velocity and 5 meters per second, and we can put in a name here as well, so we'll just call this inlet velocity. And in here we can also set goals as well, so we'll set goals for volume, flow and static pressure. Tick that box and we've got our first boundary condition. So we need to set one for the outlet as well, so again right click, insert boundary condition, and same as the outlet, just right click and select other, and that lets me select the inside face of that outlet. And for this one we'll do environment pressure. Okay, and again name that as well, so outlet pressure, and we'll set our goals as well for this one, so we'll do volume, flow and velocity. Okay, and then we'll tick that, and there we go. So it's got a boundary condition set now. So over here you can see we've got our inlet and outlet boundary conditions, and down here we've got our goals as well. Okay, so now we can just run the simulation. Let's click run, and the screen should normally pop up. If it doesn't, just go down to the toolbar and there's the screen there. Now this is going to run these calculations until we've got convergence or stability here. So that's it done now. As you can see, the bottom as well as the solver is finished. Okay, so we'll just go back into our workspace and there's our results shown there as well. So what we'll do is we'll show the flow trajectory here. So right click on flow trajectories, insert, and again we need to select the face that we want to look at. So again it'll be the internal face of the inlet we're looking at. So select, right click, select other, there we go, and then I want to decide the number of points I want. So I want to say 50. Now I'm going to use pipes for this one, but you can do the drop down, the lines, spheres, arrows, but I want to go with pipes. I'm going to measure the velocity here, so down velocity and click tick. And it's just run there, but we can't see anything because the pipe's solid here. So what we need to do is make change transparency of this pipe. So we just go up to display, down to transparency, and then set that to the value, and then click OK, and then you can see our pipes. And what we can do here is we can actually run the simulation here as well. So if you go back to that flow trajectory that we've created, right click and then click play, and there you can see the flow going through the pipe. Okay, so what we'll do is I'm going to hide that as well. So right click, hide all, and we'll show the surface plots as well to show the pressure. So right click on surface plots, insert. This is selecting the face of the inlet, but we want to use all faces, all the internal faces for this one. We'll look at contours. Again, you've got different options here, but I'm going to go for contours just now, and I'm going to measure the pressure and just tick that box, and there we have it. Contours of the inside of the pipe showing the pressure. Okay, and you can see the side here as well. Right, so what we can do as well is computational domain. We can actually get rid of that to neaten up a bit. So just right click on that and then select hide, and there we go. We've just got the pipe now, and we can still see all that bit there. Right, so what I'll do just now is we'll go down to goal plots and we'll plot the goals here. So right click, insert, select all the goals that we want to insert in the plot here, and then tick. And it's not showing up. If it doesn't show up, that's fine. Just go down to the goal plot, right click and show, and there we go. Got that there. Now what we can do is we'll actually export that to Excel as well. So we'll right click and go and edit definition. Down at the bottom here you can see export to Excel. If you click on that, that'll bring up an Excel document which will got the data table right there, number of iterations that have been run, and so on as well. Okay, so what we'll do is we'll just close out with this just now, we're not needing that. Okay, and then close it here, and next thing I'm going to show is we can actually create a Word report with this as well. So scroll down to report, and then right click, create, We've got a document open, so just ignore that. So what we'll do is get a new document here. Okay, and then I'm going to highlight that and go to pictures and charts. So I can take basically take the screenshot and put that on the document. So put that. If we put current position, it'll be at the top. End of the document will be at the bottom. Add to reports, and then move on to the IDs we want to insert as well. And what I want to do is click add to reports. And this sometimes takes a few seconds to actually go through because it's putting all that information into that report for you. Now you've got a couple of options here as well. As you can see, the bottom left ID, you can have full or short. And just select the short for this one. And just need to wait for this to load up. Like I say, it can take a few seconds, so just bear with it. Almost there. Almost there. Oh, there we go, ready. Okay. So now we just go and open up that Word document. And there we maximize the screen. And there we go, we've got this full report that is shown here. So we've got 8 pages of this data from the simulation that we've just run. Okay, so let's close out here. Don't save, we're not in that. Close that as well. Okay, so there we have it. Got just done a basic flow simulation with a pipe. Okay. So let's say that was just a flow simulation package. There are a few different simulation packages that are available through SolidWorks, 4 in total. So we're just going to go through what we've got here. So first thing we've got is SolidWorks Simulation Express. Now this comes as part of your standard SolidWorks package. So you can run basic simulations on this, but you can only simulate on a single part. You can't actually simulate on an assembly. So if you are looking to simulate on an assembly, you'll actually need to upgrade to one of the other packages. So the next one up we've got here is the SolidWorks Simulation Standard. And then up from that one we've got SolidWorks Simulation Professional. And then at the top of the pack we've got SolidWorks Simulation Premium. So all these share similar features, and then as you go up the pack, like I say, you'll get extra features there as well. So if you want to have a bit more information about all the different features that are available in these packages, just go to solidworks.com and you can get a comparative table right here, and that will show you all the different features that are available in each of the 3 packages. And like I say, SolidWorks Simulation Express, that is available as part of the standard SolidWorks, but like I say, it is quite limited in what it can do. Okay, just want to thank you for watching this video. For more information, like I say, you can go to www.solidworks.com. For more information on our company, MGC Technical Service, you can go to our website, www.mgctechnicalservice.co.uk, or you can email at sales@mgctechnicalservice.com. We're on social media as well, LinkedIn, Facebook, Twitter, and we've got a channel on YouTube as well. Okay.